Welcome back to the channel. Today we're talking about machine libraries. Specifically, how do we import our machine, which is a host mini mill, into Fusion? And then how do we add work holding, which happens to be our fifth axis, which allows you to switch work holding very quickly. So how do we also switch it within Fusion and have it all simulate accurately? Stick around. I'm going to show you how. Okay, to get to the simulation step, there's 5 steps we have to do beforehand. First, we have to design our work holding in the CAD file. We need to modify the CAD file of the machine. We're going to have to add the machine into the machine library. We are then going to have to build a CAD file with the work holding and the part to be machined. Then move to the manufacturing workspace, do a setup, create the operations, and then finally be able to simulate it within Fusion. First off, I create all the CAD work holding for the students, and it's in a shared project. But for those of you who need to know how to do it, I'm going to go ahead and demo it now. So first off, I save them. There is an order to the numbering system, but we're going to go ahead and make a number 7. So I'm going to go ahead and save the file as just number 7 within my work holding for milling machines. I also do this for lathes. And then I'm going to go ahead and I'm going to start adding components to the workspace. So my work holding supporting files is where I store all my vices, plates, and all the things that go on our machine. So we're going to start with a base plate. The most common base plate I buy is this double base plate from Fifth Axis. You can download it from their website. It comes in as a number, but I just change its name to double base plate. And then I go ahead and I insert it into the current design. Now, I'm going to go, I don't really care where it goes in right now. I'm going to have to move it in a second. But the big thing I don't want is I don't want it linked to the original base plate. Breaking the link is going to be very important in this whole process. So I'm going to right click and say break link. And it moved in a way I don't want, but that's okay. The second thing is I want this just to move around as a unit. I don't actually care that all these components are movable. Also, I'm not anywhere near the max mass of my machine. And if you were, you could actually put every bolt, nut, washer into this, and it will give you a mass of how much your whole project weighs if you are pushing the limits of, say, the mass your mini machine can hold. That's just a side note. So the first thing we're going to do now is we're going to unground from parent, and now it's free to move. It's also not a rigid group. So the second thing we're going to do is go right click rigid group, and I'm going to make this a rigid group so all the subcomponents move as one. Now, the most important step is I need the base the bottom of this plate to be at the origin, because that's going to be very important when we set the origin on the CAD file for the machine. So when they come together, they line up. So to do that, we're going to just use a symbol J on the keyboard for join. I'm going to find the center of it, which is this point here. And then I'm going to turn on the origin, and I'm going to put it here. And I have to orient it in the proper orientation. So X, Y, Z matters. These go in my machine along the long axis is along the X. So I'm going to go ahead and rotate this 90 to allow it. When I click OK, those parts will move. And now we have it. If I really wanted to get critical, should go in and rotate the other way, because this is actually the back side, because the open is on the back side and the torque specs are on the front side. So I'm going to edit the joint, and I'm just going to move it 180 degrees and get it going the right way. And you can see the torque specs are on the front, which is how my machine is. We're going to need to ground this or pin it in location so it won't move, so that when we do other things, we don't have problems. It's a very important step. So the next thing is I can turn off the origin. I don't need to see it anymore. Okay, our next step is we need to insert our vise. I've moved over to my fifth axis vices, and I'm going to right click. I know it's behind me, but I'm going to right click and say insert into current design. And our vice comes in. We're going to go ahead and click OK. And the very first thing we're going to do is break the link. One thing this vice is going to have is we're going to actually model the stock that we would use with parameters so we could change the size. into this work holding. So when we actually go to set this up and do the CAD files later, we'd actually take the part we want to machine, assemble it inside the stock as we hope to actually machine it, change the parameters so that the stock is the correct size, and then we'll move through the process. So to do that, we need the vice jaws to be dynamic within parameters. So the vice is not fully assembled right now. We're going to have to assemble it in this file. So first, we're going to do is I want to get rid of the origin. I don't need to see it. Second, I'm going to take the base and attach it to the base plate. I don't have the pins. I could go to all that effort. It just makes the file bigger, and they're not functional for the CAD, so we're just going to skip it. So on the keyboard, I'm hitting J for join. We're going to assemble the bottom of the vise with the center of the plate right there. And we're going to go ahead and click OK. Now, the jaws need to be linked together with the carriers. So I'm going to hit J. I'm going to grab any point on the jaw and any point on the carrier that matches and click OK. And then I'm going to hit J on the keyboard. Oops, before I do that, I'm going to move them out of the way, hit J, and I'm going to pick the carriers and the bottom of the jaw. Now our next step, we need the dynamic parameters put in, so because that's going to be needed to do the next set of assemblies. So we're going to go ahead and go to modify, change parameters, and we are going to add 3 parameters. And I'm going to go ahead and click OK here. And the first one, I'm going to call them all stock underscore depth, which would be our y-axis. And I'm going to go ahead and set that to 3, and I could put down here y-axis. And then we're going to hit stock underscore width, and this would be also 3, and we're going to set this as our x-axis in the comments. Oops, I got those capitalized. I don't know if I did the other one capitalized. And then we're going to go ahead and do height, or stock, I'm sorry, underscore height. And we're going to set that to 1, and we would say z-axis, which will appear in the comments. And these all can be edited in the future to give us the proper stock height. And then I like to check these because depending on other factors, sometimes they get buried into things. These will always put them in the favorites. And go ahead and click OK. Now, one piece of information we need, which we'll jot down on a piece of paper, is we are going to use the center of this bar here as our kind of driving point, but it is not level with the ways of the vise. So I need to inspect that difference, and it comes out to 0.011. So we're going to need that number for later. So I'm going to go ahead and hit close, and I'm going to go J for joining. It doesn't really matter which jaw you start with, front or back, but I'm going to pick the bottom front edge of this jaw. And I am going to click here, which actually puts it wrong, as you can see right there. But if I move it up, I can move it up 0.011, and now it's on there. Now I'm also going to slide it in this direction, and I am going to actually put this parameter as, and we're going to have to make a modification in a few minutes, but we're going to put this parameter is stock, and this is depth divided by 2, because remember these are self-centering jaws, so we only want 1/2, and we're going to go ahead and click OK. And now we're going to do, instead of doing that same procedure, which would be fine, the easier way to do it is just to go J, take the center of this vise and the center of this vise, and then set the distance apart to be stock depth. If I can spell it, there we go, and click OK. And now you can see that it is working. And if we go into parameters, we can do change, and we're going to change that stock depth to 2, and now the jaws change together with the vise. Now, one problem we have is we are actually going to use these Talon grips on the top to attach our part for this example. So we need to now know what the change is so it actually grabs on this edge versus this edge. So I'm going to use inspect, and I'm going to come in here and I'm going to inspect between these 2 surfaces, and the delta is 0.1. So the delta in total is 0.2 if we're going to do the same thing here. So what I'm going to do is I'm going to open up these relationships, and these are the, well, I can come down here to these relationships and go to the last two. So I'm going to edit the joint, and I'm just going to say, take the stock depth and subtract 0.2 from it, and that will close the distance. And if I go back to this joint, I'm also going to take this one. I'm going to have to put parentheses because I need to take the answer and then subtract it by 0.1. And now, oops, I did something wrong. Edit joint. Oh, it needs to be by 0.1, not 1. And now, if we inspect between these jaws from here to here, it should be exactly the number we were looking for at 0.2. So we are most of the way there. We're going to do a few more things. One is we're going to draw the stock. So I'm going to go ahead and create a new component, and I'm going to call it stock. And I'm going to draw it. It doesn't really matter where because we are ultimately going to assemble it. So I'm actually going to turn these things off so I can start a sketch down here at the origin. I am going to use a center justified rectangle, and I am going to just call it, this would be stock depth, tab, stock width, enter, and we're going to go ahead and extrude that to stock height. And then to make our life easier, I'm actually going to make the stock out of glass. So I'm going to right click on stock, go to physical materials, and set it to glass. That way when we do the assembly later, oh, I got an open glass. That way when we do the assembly later, it's clear and you can see your part on the inside with ease. This would be also a factor if you had a mass issue with your machine, so be aware of that. So now we're going to actually join this onto the part. So I'm going to go ahead and hit J. And because this is a rectangle, it doesn't really matter. I'm going to click the center bottom, and then I'm going to turn on these other features. Oops, my mistake. I'm going to turn them off. I do not want the center bottom. I want the edge here, and then turn on the center features. And I am going to select the edge, not that edge, this front edge. And I can revolve it around 180 degrees. And then I need to offset it back to 0.1. I guess it's negative 0.1. There you go. And we click OK. And now if I go back to the main page, here is our assembly. And we are going to go ahead and check that it works by going to change parameters. We're going to change the stock depth, which is the only one that matters, to 2.5. Press enter. I can see it move in the background, and you'll notice that it all sticks together as normal. So now we have the real important part of the work holding together, but if we want to simulate accurately and show us any collisions, we need to add all the other features. The big feature on our machine is we have an OTS probe over here on the back right-hand corner. So I'm going to go into my files, work hold supporting files, and I believe at the bottom of this list, I have that probe. I'm going to go ahead and right-click and say insert into current design. And it kind of comes in the middle because it comes at the origin. I'm just going to slide it out of the way and click OK. And then I'm going to go J to join, and I am going to grab the bottom of the probe. And I am going to grab this corner right here, and I'm going to invert it, and I'm going to rotate it into the degree it goes. And then I know that mine happens to be 2 5/8 in this direction, which is actually X, but it's labeled Y. So 2.625, and it is offset in X 1.6 is where ours ends up. Note, when we do this with the machine, it actually doesn't line up on the same T-slots, but my machine is different than the machine in Fusion, slightly with the T-slots, and I care more that this is accurate to my machine than to the T-slots. So if we had any other features to add, a rotary, any other work fixtures that may be in the machine, we could go ahead and continue to add them, but this is the basics. I don't need to see all these joints, so I'm going to turn off relations. And then I'm going to go ahead and unbreak this probe. It wouldn't really matter because we're not going to modify the probe, but good habit to get into. And I'm going to go ahead and hit save. The next step is we need to get a copy of the machine model into Fusion, and we're going to get that from Autodesk. We do have to download to only upload. Best method, but it's a method that works. So we're going to switch to the manufacturing workspace. We're going to go to the machine library, and we are going to click on Fusion libraries. I'm going to go ahead and switch over here to Haas, and then I'm going to scroll down and find the mini mill. And there it is. And then I am going to actually export it. And it's going to download it, and I want to make sure it is downloaded as an F3D. And we're going to go ahead and hit export, and it's going to download. In the meantime, while it's downloading, I'm going to hit close, and then I'm going to go over here to upload. And I'm going to upload it into this folder where I store stuff. Here is the Haas mini mill. I'm going to go ahead and click OK and upload, and it's going to take a moment for it to go through the uploading process. Now, unfortunately, it appeared behind me on the screen, so I'm going to go ahead and double click on it to open it. So it's going to open over here, and we're in the design phase. Now, the real critical component here is we need the origin to be of the machine to match the origin of the work holding, because when we bring them together, they're going to line up origin to origin. So we want to essentially match where the origin is in this model here with the origin of the work holding. The work holding origin was at the bottom of the base plate, so we want to basically put the origin of the machine the center of the table. Some machines it's not the center, and you can shift it left or right as needed. So what we're going to do here is we're going to go ahead and turn on origin. And this one came in, and it looks like it's come in exactly where we need it to be. Not all machines do. If it did not, I would use an assembled joint to move these to that location. So now that we have both the work holding done and the machine, our next step is we have to create a machine library machine. So we're going to switch back to manufacturing, and we're going to go ahead and click on machine library. Now, I'm going to do mine in my local. Normally, I would recommend doing it in the cloud. I already have a bunch of machines, so we're going to use local just to keep them separated. We're going to hit plus and milling machine. And then we're going to go ahead and label it. And I'm going to call this Haas and then demo, because this is an example, and the mini mill. So mini mill demo. That way I don't use it in the future because I already have the one that works. And I can write in a description here if I want. Okay, for capabilities, we have 10 tools, and our maximum feed rate is 650 inches a minute. So we're going to go ahead and hit 650 and enter. Oops. We'll go to edit again. It'll bring us back up. We're going to go back to capabilities, 10, and make sure this has 650 inches a minute. Sometimes it converts it to millimeters, and that's like 25, and we'll have all sorts of problems. The real one is kinematics, I think is how it's pronounced. We need to get this in the proper orientations. Now, the real way to think about this is think from the ground up. So as we get to each area, starting at the bottom, so we have the base doesn't move. The saddle that controls the y-axis in a mini mill moves on top of the base. So the very top level needs to be the y-axis. So it's hard to pull y up. It's easier to pull x down. So I'm going to move x below y. So the y slides front to back, and then the x slides on top of the y. So we have xy. And then on top of that is the table. Now the z is on the head. So we're going to pull the z down under the table so it's on the head. And now we have the machine's kinematics, how it moves, oriented properly. Okay, for the rapids, we need to put in the rapid. For the mini mill, the rapid is 650 inches per minute, and the max feed rate is 500. Now, we would also do that for the X, which I've already done, and for the Z, which I've already done. It needs that in order to read the tools properly. So next step is post-processor. We're going to click on this, and the post-processor we're going to use from the Fusion library, once again, use Haas automation, is the next gen controller post processor. So I'm going to go ahead and click on this and then hit select, and it's going to ask us where we want to save it. I am going to save it locally, not in the cloud. Cloud is recommended. That way you can use multiple computers. If you save this on only the machine you're on now, that's the only machine you'll ever be able to use it on. So go ahead and copy my post. Additional settings we're not going to play with. You can modify how fast the tool changer is. This will give you better numbers on machining time if you're looking at that. Now for the model, we downloaded a model that we know has the proper origin. So we're going to use that one. So we're going to go ahead and hit select. Mine is in this folder, so I'm looking for Mini Mill. It's the one that I downloaded the latest, which is this one here. And I'm going to go ahead and hit select. Now I'm going to go into Machine Builder. Yes, I want to save it. And it's going to bring up the machine. But this is a model of the machine, but it's not editable in that way. And we can see that our origins match, but more importantly, we need to verify a couple of steps. One, that all the axes move in the correct directions, and two, where our stock or where our file will load into and where the tool goes. So first, let's check the axes. We're going to go here to Machine Preview, and there's these slides. And it doesn't matter that it slides through the machine. What really matters is it moves the way the machine moves. X moves on top. Yep. And Z should come up and down. So those all work. We can click on the home buttons, but you can also just hit click OK. Now, the other thing we need to double check is we are going to click on Machine Setup. And these top two matter the most. Where is the part? Right now, the part is right here at the center. That's what we want, so that's a good thing. But when we click on Tool, that's up at the top, also where we want. It does not always come in this way for your machine. And then we can go ahead and click OK. So in theory now, if all is programmed correctly, when we bring the work holding in, it will align point to point here, setting it up on the table like it's in our machine, and the machine kinematics will move in the motions that we plan. We're going to go ahead and hit Finish Sketch or Finish. We're going to go back over here. It's thinking through the machine library. And you notice we have this Haas demo, Mini Mill demo in our local library. We're going to go ahead and hit Close. We are going to get out of this as well. We don't need this anymore. And we're going to do a quick demo of how all of this would come together. So the very first thing is I am going to need to use a part. So we're just going to use this simple part right here, and we're going to put it together with our work holding and then the setup and do a simulation. So we're going to go to Home. We're going to start with the work holding because we need it to be on the bottom. So I'm going to go ahead and open work holding, the milling, and then we are worked with tool number 7. And I'm going to insert that into the current design. Now I know because I designed all these parts, I'm going to go ahead and click OK. First thing I'm going to do, break the link because I don't want to make the changes to the stock here that will affect my original. I'm going to change the stock size first. I know this material is aluminum and it's 2 inches by 2 inches by 1 inch thick stock is what we're going to use to manufacture it. So we're going to go into the parameters and we're going to go ahead and change. We can close this. The depth is 2, the width is 2, and the height is 1. And there is our stock. So the next thing we need to do is put the part we want to machine into the work holding. I've already navigated to that. I'm going to right click and say insert into current design. It's going to come in. We're going to once again slide it temporarily out of the way. And then just like a part, we're going to assemble it with a joint. J for join, center of the part, center of the top. Obviously, that's not how it's going to get machined. We're going to flip it over. My standard policy is we're going to push it inside the stock by 20 thousandths. So I'm going to go ahead and go to the Z and say negative 20 thousandths, which will allow us to have some material to do a face cut and remove. And we can see that this is the raw stock and there is our part. And we go ahead and click OK. The next step is we need to save it. So I'm going to go ahead and save it, and I'm going to call this demo machine library. And go ahead and hit save. It's important you cannot work with the machine if you haven't saved it. Next step, over to manufacturing. We're going to go ahead and hit setup. And then we are going to select our machine. So it'll automatically go into our machine library. I'm going to select this machine. You can see it has the name of the machine there. We are doing milling. We're going to change this here in a second. We're going to go to model. And the easiest way to get to this is to actually open all these files and select the model. It'll put it there. If we want to change the stock location, we could, but I want it, we're going to right click and go orthographic. We want it on the very top of the stock, which is exactly where we want it, because we're going to do a probing operation to make this work. And then for fixture, we can open up this 7 and we are going to select all of these things. I'm going to hold down control except for the stock. Oops, I should close this and select that. We do not want the stock. And that way, oh, and we want also this and this. And that way, if the machine hits any of these things, it will warn us that we have a collision. Obviously, we want it to hit the stock, so we're not going to select stock. We're going to go ahead and move to the second one. We're going to pick from solid, and we are going to pick the stock. We no longer want to see the stock after this point, so we're going to go ahead and hide it at this point. And then we're going to go to positions. You do have to normally go from fixture box to point. And then if we look at it, you'll notice it came right into the machine where we wanted it to. And then we would go through here and we would set in our program numbers. I'm not going to do that at this time. And we go ahead and click OK. Okay, we're going to run two machine operations, probing and facing, so we have something to show in the simulation. So the first thing is we're going to go to inspection, and we're going to hit probe, and then we're going to select from the tool library the Renishaw probe. Then I'm going to select the sides of this. There's a very small difference between the part and the stock, so I can go ahead and use the model. And it gives us a probing operation, and I'm going to go ahead and click OK. Next, we're going to do facing, so I'm going to switch back to milling, and I'm going to go ahead and hit face. I'm going to select from the tool library a facing mill. I have a whole video on how to machine this part on my channel, so go ahead if you want to know how to do the whole part. I'm only showing part of it very quickly, and watch that video. So we selected the facing tool. There really isn't much more to do, so I'm going to go ahead and click OK. Now that we have two operations done, we're going to go ahead and try simulation. Okay, it says there is 4 errors. Let's see where those errors are. Let's go ahead and hit play, and it's showing it probing and probing. I think it's selecting those errors because of the difference between the stock and the part. But overall, it gives a good simulation of how it would work. It even shows us where the errors are. To fix that, we would go back into the probing, modify it from model to stock, and then select the stock faces. But that's an overview of how to create a machine in the machine library. Now, this whole process could be repeated with a different work holding. So all of my work holding that I've created, if I wanted to use a different vise, like this vise, I would just do all the same operations here, use the same tool, it would appear in the same spot, and all of this could be repeated with ease. Hopefully this gives you a better idea of how to set up a great machine library that will work in your classroom or in your machine shop. Thanks for watching, and I'll catch you in the next one.